In this video, we are going to be looking at different ways to find greatest common factors and least common multiples. So first of all, greatest common factors or greatest common divisors is when if you have A and B that are whole numbers that are not both 0, it's the greatest number that divides both of them. So it's the largest factor that two numbers have in common. And least common multiple, if A and B are natural numbers, the least natural number is a multiple of both A and B, called the least common multiple. So just try and remember, factors are smaller than the numbers we start with. Multiples are larger than the numbers we start with. So we're going to talk about different ways to find greatest common factors and least common multiples. So first of all, making a list. So if we want to find the greatest common factor of 18 and 45, we want to list out the factors. So what times what makes 18, first of all. So 1 and 18, 2 times 9. So using our divisibility rule, so 3 times 6, 4 is not going to work. 5 does not work, and then we get back to 6. So it's just 1, 2, 3, 6, 9, and 18. So for 45, we would have 1 with 45. See, 2 is not going to work. 3 should, so it's 3 and 15. 4 won't work. It ends in a 5, so 5 and 9. 6 will not work. 7 does not work. 8 does not work. So 1, 3, 5, 9, 15, and 45. Okay, so what is the largest one that they have in common? It should be the 3. So they both have a 3 in common. So the greatest common factor between 18 and 45 should be 3. Okay, and then try this with 14 and 22. Take a minute, pause the video, see if you can figure this one out on your own. Okay, so 14, 1 and 14 make 14, 2 and 7, let's see, 3 will not work, 4 will not work, 5 will not work, 6 will not work, and then we're left with back to 7. And then 22, 1 and 22, 2 and 11, let's see, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7, 8, 9, 10, and then you're back to 11. So the largest number they have in common is a 2. Okay, so there's how we make a list for greatest common factor. Now we can also do this for least common multiples. So with least common multiples, we also want to make a list. So generally we just start by listing off the numbers and then we just stop at some random point. So multiples of 18. So 18, 18 more than that would be 36. 18 more than that would be 54. 18 more than that would be 72. 18 more than that is 90. 18 more than that is 108. Okay, so let me stop right here and then move to the list for 45. So 45, that's not on the list, so we keep going. So next number is 90. So there is the smallest number that they have in common. So least common multiple for 18 and 45 should be 90. Okay, now why don't you try this for 14 and 22? So take a minute, pause the video, and unpause it when you're finished. Okay, so for 14, let's see, so it'd be 14, 28, 14 more than that, so 42, let's see, then that would be 56, 70, 84. All right, let's jump down to 22. So 22, 44, 66, 88. Okay, nothing in common yet, so we have to keep going. So 22, so that would be 110, 132, 154, 176, 198, 220. Okay, so let's go back to our list for 14. Let's see. So 98, that's not on the list. So 14 more. 112. Nope. 14 more. 126. No. 14 more would be 140. So no. And then 154. Oh, here we go. 154. So the least common multiple between 14 and 22 should be 154. Okay, so this will always get you to the answer. Sometimes it's a little more efficient than other times. So maybe you have to make a giant list of numbers. But this is it's a good strategy for if you have two kind of smaller numbers. If you're trying to find the GCF or the LCM. Okay. Oh, I forgot to mention what page number we were on. So now we're on page 112. All right, so another way that you could do greatest common factor and least common multiple is through prime factorization. So maybe you remember doing factored trees to find greatest common factor and least common multiple. So for greatest common factor, if we want to find the prime factorization, so if we start with 270, so what times what makes 270? So let's do 10 and 27. Okay, those are both still composite. So 10 is 2 times 5. Those are both prime, so we're done. And then 27 is 3 times 9. 3 is prime, but 9 can be broken down into 3 times 3. Okay, so 270 is 2 times 3 times 3 times 3 times 5. And 630. So 630 would be 10 times 63. 10 is 2 times 5. 63 is 9 times 7. And then 9 would be 3 times 3. So 630 would be 2 times 3 times 3 times 5 times 7. Okay, so you may remember for school, greatest common factor would be all of the factors that they have in common. So what do they have in common? They both have a 2, they both have a 3, they both have a second 3, and then they both have a 5. So one way to do this is to do 2 times 3 times 3 times 5. What they have in common, and let's see, what is that? 2 times 5 is 10, 3 times 3 is 9, so 10 times 9, this should be 90. So 90. Okay. Now, another way to do this, it mentions up here in the directions a Venn diagram. So if I were to draw a Venn diagram of this situation, so I didn't leave myself a whole lot of room, so let me turn my paper sideways a little. So a Venn diagram, we have two overlapping circles. So if one circle represents 270, the other represents 630. What factors did they have in common? They had a 2, a 3, and a 5 in common. And then 270 also, if you look sideways, had this other factor of 3. And then 630 also had a factor of 7. So our Venn diagram would look like that. So instead of trying to remember, oh, it's the factors they have in common, if you make a Venn diagram, you should notice that the greatest common factor is in this overlap part. So it's the factors they have in common, 2, 3, 3, and 5. Okay, so let's try this for the 504 and 3675. Let's try making a Venn diagram. So again, you can try this on your own if you want to pause the video and then unpause it when you're finished. Okay, so prime factors for 504. So 5 plus 4 is 9, so I know this is divisible by 9. So 504 divided by 9 is 56. Okay, so 9 is 3 times 3. And 56 would be 7 times 8. So 7 is prime. 8 is 4 times 2. And 4 is 2 times 2. So our prime factors are 2, 2, 2, 3, 3, and 7. So maybe I'll write those out for you. All right, and then if we try this with 3675, well, it ends in a 5, so I know 5 has to go into this. So 3675 divided by 5 is 735. Okay, so again, it ends in a 5, so I know 5 has to go into this using our divisibility rules. So again, divided by 5 is 147. Let's see, 7 plus 4 plus 1 is 12, so I know that 3 should work. So let's see what 147 divided by 3 is. That's 49. And then what? 49 is 7 times 7. So 3675 should have prime factors of 3, 5, 5, 7, and 7. Okay, so if we were to make a Venn diagram of this, what do they have in common? What do they have in common? Let's see, no 2s. They have 1, 3, and 1, 7. So, let's see, 504 still has a 2, a 2, a 2, and a 3. And 3 and 7 still have 5, 5, and 7 factors left over. So greatest common, so notice I switched to GCD. So greatest common divisor, greatest common factor is what is in the overlap. What do they have in common? 3 times 7, so that is 21. So 21 is the greatest common factor. Okay. All right, so what about least common multiples? So the nice thing about this method is that you would be making a factor tree again, and you can see from over here we have already done that. So I'm just going to copy my work over here for LCMs when we're talking about it. So we said that 270 factored out to be 2 times 3 times 3 times 3 times 5, and 630 had a prime factorization of 2 times 3 times 3 times 5 times 7. All right, so for least common multiple, this one's a little trickier. So with greatest common factor, we found out what they had in common. So the way that you find least common multiple is you take the largest amount of each factor that exists. So what I mean by that is we start with our first factor. We have a 2. So there is 1, 2 over here with 270. There's 1, 2 over here with 630. So we would take 1, 2. Then over here we have 3 3s, or we have 2 3s. So we take the larger quantity. So it should be 3 3s. And then we look at the next factor. We have 1, 5 compared to 1, 5. So we should take 1, 5. And then we have no 7s compared to 1, 7. So we should take the largest quantity, which is 1, 7. All right, so that means the least common multiple is whatever this is multiplied together. So let's see, this is 10. Then we have, so we have 10, 27, and 7. So 10 times 20, trying to do this in my calculator. 2 times 3 times 3 times 3 times 5 times 7. So that comes out to be 1890. So our least common multiple is 1890. Okay, So one thing you should notice, again, this could be much easier with a Venn diagram. So I'm just going to copy this Venn diagram that I drew sideways over here a little better so you can see it. So we have 270 and 630. So in the middle we have a 2, 3, 3, and 5. So 2, 3, 3, and 5. And then we had an additional factor of 3 with the 270, and then we had an additional factor of 7 with the 630. All right, so take a look at what the LCM ended up being and this picture of the Venn diagram. You should notice something. So what do you notice about the factors in the LCM compared to this picture? So you should notice that all of the factors are the exact factors listed in this entire Venn diagram. So we have the 2, 3, 3, and 3. So we have 3, 3, and 3, the 5, and the 7. So you can use a Venn diagram to find both GCF and LCM by GCF being in the middle and the LCM being the rest of the Venn diagram. So with that in mind, we can try this with 504 compared to 3675. So take a look at our Venn diagram over here. So based off of this Venn diagram we did for GCD, what is the LCM going to be? So it should be everything in this Venn diagram. So it should be 2, 2, 2, 3, 3, 7, another 7, a 5, and a 5. Okay, so you don't necessarily have to write them in order, but it's all of the factors from the Venn diagram, so much easier than trying to look at the quantities. So 2 times 2 times 2 times 3 times 3 times 7 times 7 times 5 times 5 is 88,200. Okay, so we definitely would not want to make a list. It would be much easier to use our Venn diagram. If you tried to use the rule of take the largest groups of each number, let's take a look at that. So you have 3 2s compared to no 2s, which is why we took 3 of them. We have 2 3s compared to 1 3, which is why we took 2 of them. We have no 5s compared to 2 5s, so we took the 2 5s. And then we had 1 7 compared to 2 7s, so we take the larger group, the 2 7s. Okay. So this is based off of this Venn diagram. Okay. So that is our second strategy. So again, making a list would be really, really difficult and take a really long time. So this one is a nice alternative. So prime factorization with a Venn diagram. Okay. The third method we are going to talk about is called stacked division. And stacked division has lots of different names. So I've heard it called the ladder method, the boot method, the upside down birthday cake method. So the idea is that you are pulling out common factors. So if I wanted to find the greatest common factor of 24 and 32, I could write 24 and 32. And then what is a factor that 24 and 32 share? What is a number that goes into both of them? So maybe it's a 2. So 2 goes into 24 12 times, and then 2 goes into 32 16 times. Okay. All right, now, do they have another factor in common? So yes, they also have another 2 in common. So a factor of 2, so 2 goes into 12 6 times, 2 goes into 16 8 times. All right, and then do 6 and 8 have something in common? So yes, they also have a factor of 2. So then we're left with 3 and 4. All right, and then 3 and 4 do not have any common factors, so this is how you know you are done with your greatest common factor. So what were the factors that they had in common? They were over here, 2, 2, and 2, which is 8. So maybe you could have seen right at the beginning that 8 was what they had in common, and you could have pulled the 8 out immediately, or maybe you had gone with 4 to start with. I just did 2, 2, and 2 for dramatic effect. So can you tell this kind of looks like an upside down birthday cake, or maybe an upside down wedding cake? Something like that. Okay. So this method also works if you have more than 2 numbers. So what if you had 3 numbers? So if you had 8, 14, and 20. Okay, what do 8, 14, and 20 have in common? What factor? So they have a 2 in common. So if you take out, let's see, a factor of 2, 8 divided by 2 leaves you with 4, 14 divided by 2 leaves you with 7, 20 divided by 2 leaves you with, not 2, how about 10? 10. Okay. And this one isn't as exciting because do these 3 numbers now have a factor in common? So no. 2 of them do, which we'll talk about in a minute with the least common multiple. But because of the 7, 7 doesn't go into 4 or 10. So this one, the greatest common factor, is the only factor we were able to pull out, which is a 2. Okay, so that's the greatest common factor. All right, so then how does this work for least common multiple? So we would use the same upside down birthday cake or stack division, whatever. So we start by pulling out the common factors. So I'm just copying this again. Okay. So if you remember what we did last time with the Venn diagram, so when we had 24 and 32, this is telling us we have common factors of 2, 2, and 2. The 24 still has a 3 as a factor left over, and 32 still has a factor of 4 left over. So based on what we just did, the LCM should be all of the numbers that are in this Venn diagram. So it should be 3 times 2 times 2 times 2 times 4. So with that in mind, where do we see that in our upside down birthday cake? So it's going to be the greatest common factors plus the bottom layer of the cake. So this is where it's sometimes called the boot method. So does that kind of look like a boot you might wear, or a sock, or a golf club? So something to that effect. So least common multiple are what they have in common plus the remaining tier. So least common multiple in this case will be 2 times 2 times 2. So 8 times 3. Oops, I wrote 8 times 3 times 4. So 8 times 3. So 24 times 4. So that's going to be 96. Okay, so 96. Okay, so how does that work for 3 digits? So we had our 8, 14, and 20. So we said they had a common factor of 2. So we had 4, 7, and 10. So this one's a little bit different because in this case, we do have something still in common among 2 of them. So because 2 of the numbers still share a common factor, we want to also pull that out before we find the least common multiple. If we don't, since they have a common factor, if we just take the 2 and then this bottom tier, our LCM is actually going to be off a little bit. So we want to pull out another 2. So 4 divided by 2 leaves you with 2. 7 can't go into 2, so it just stays 7. And then 10 divided by 2 is 5. So we actually made an additional tier. Although remember, this 2 is not included really in the greatest common factor since it was only shared by 2 of them. But then once we have everything factored out and none of the numbers have anything in common, we would be taking that bottom tier as well as the common factors that were pulled out. So the least common multiple for this one would be 2 times 2 times 2 times 7 times 5. So 8 times 7 would be 56. 56 times 5 would be 280. So our least common multiple between 8, 14, and 20 is going to be 280. Okay, so that is the third method, stacked division. Okay, and then we have one more method to talk about, which is the Euclidean algorithm. So the Euclidean algorithm helps us find GCFs only. It only tells us how to find greatest common factor. Then we have to do something else in order to find the least common multiple. So Euclidean algorithm is great to use if you have really large numbers. So we have in our first example 624 and 1044. So we don't want to make a list, and we don't really want to make a factor tree that's going to be very large, and probably a birthday cake or stack division would be very large also. So instead we use Euclidean algorithm, which is basically just repeated division. So first of all, you want to see how many times 624 goes into 1044. So if we start with 1044 divided by 624, how many times does that go in? I believe it's just once. So if we take out 624, we have a remainder. So our goal, we know we are done when we no longer have a remainder. So right now we have a remainder of 420. So we need to keep going. So now we want to see how many times this remainder goes into our divisor. So next we want to check how many times does 420 go into 624. Okay, so take the remainder into the divisor. So that's only one time. So what is our remainder? So 624 minus 420 is 204. So we have a remainder, so we need to keep going. So now this time, how many times does 204 divide into 420? So I think that's going to be twice, because that would be 408. That leaves us with 12. Okay, so we keep going. So then how many times will 12 go into 204? So 12 divided by 204, let's see, 1, that leaves us with 84. 84 divided by 12, that looks like 7 times. So 7 times 12 is 84. So we are left with 0. So now we know that we are finished when we have a remainder of 0. So our last divisor is going to be the greatest common factor. So the greatest common factor is 12. Okay. So doing some repeated division. All right, so why don't you take a minute and try this one, the 1649 compared to 18,411. So pause the video and then unpause it when you are ready to check your answer. Okay, so first of all, we want to see how many times 1649 divides into 18,411. So let's see. Looks like it's 11 times. So let's see, 1649. So 1841 minus 1649 is 192. Bring the 1 down. So minus 1649 is 272. Okay, so we have a remainder. So how many times does 272 go into 1649 is what you would want to check next. Okay, so 1649 divided by 272. Looks like that's 6 times. So 272 times 6. That is 1632. So that leaves us with 17. All right, so we keep going. How many times does 17 go into 272? Let's see, this would be once. So that leaves us with 102. So 102, that looks like 6 times, and it comes perfectly out to 102. So we have 0 as the remainder. So finally, so our last divisor is 17. So the greatest common factor between 1649 and 18,411 is going to be 17. Okay, so a lot faster than any of our other strategies so far. Okay, so this one is great for large numbers. Okay, so we have found the greatest common factor for each of these. However, we don't know yet how to find the least common multiple. So normally, if we were in person, I would be doing this activity called Mark's GCD LCM problem, which is on page 115 and 116. However, in the interest of saving some time, I am just going to reveal to you the point of this activity. So the point of this activity is that you will discover, it actually says it right up here, so maybe we will do one of these. So let's say we have 16 and 40, and the LCM, it wants you to find the LCM, the GCD, the two numbers multiplied together, and then the LCM and the GCD multiplied together. So we won't do this full activity, but we'll do an example. So let's see, so 16, let's see, maybe I want to do, let's say like birthday cake, or stacked. So what do 16 and 40 have in common? They have a factor of 8 in common. So 8 goes into 16 twice, 8 goes into 40 5 times. So then we're done. So greatest common factor is going to be 8. Least common multiple would be 8 times 2 times 5. So that would be 80. Okay. Then it wants you to multiply these two numbers together. So 16 times 40 is 640. And it wants you to notice then what is the LCM times the GCD. So 80 times 8 is also 640. So the whole point of this activity that we are about to skip is that when you have two numbers, if you multiply them together, their product will be exactly the same as the product of their GCD and their LCM. So if we multiply those two together and multiply those two together, they should be the same. Now it should make sense because if you think about the numbers 16 and 40, if we just compare, how would we go from 16 down to 8? You divide out a 2, right? So it's going down by 2. So this set of numbers is going down by 2. So what is happening from the 40 to the 80? It's increasing by 2. So all we're doing is taking a 2 from the 16 and putting it where the 40 is to change it into 8 and 80. So we will end up with the same factors. Okay. So let's skip ahead to page 117 where we're looking at our numbers. Okay, so I think my video glitched, so I apologize. So let me review that again. So the LCM and the GCD have the same factors as the two numbers being multiplied together. So we have this GCD LCM rule that says if we multiply any two numbers together, then that will be the same product as if we take their GCD and LCM multiplied together. So we previously found through the Euclidean algorithm that the GCD of 624 and 1044 were 12. So if I take the two numbers multiplied together, that should equal 12 times whatever the LCM is going to be. So 624, let's see, times 1044 is 651,456. So that should equal whatever 12 times the LCM is. So if you divide both sides by 12, the LCM is going to be 54,288. Okay, so using the GCD LCM rule. All right, what about for the other one? So what about finding the LCM of 1649 and 18,411? So the product of 1649 and 18,411 should be equal to the GCD, which we found was 17, times whatever the LCM is. So 1649 times 18,411 is 30,359,739. That equals 17 times the LCM. Okay, so then divide both sides by 17. And that should be 1,785,867. It's going to be the LCM. Okay, so again, much easier than trying to make a list or trying to find factors using the GCD LCM rule. So now, as long as you know, there are 4 numbers involved, so as long as you know 3 of them, you should be able to find the 4th one. So, using this rule. So there's a couple of word problems down here below. So it says the LCM of 2 numbers is 8,680. The GCF is 20. One of the numbers is 280. So what is the other number? So our 2 numbers are A and 280. And that product should equal the product of their LCM and their GCF. So 20 times 8680. All right, so 20 times 8680 is 173,600. So if we divide both sides by 280, we can find that missing number. So divided by 280, so it looks like it's going to be 620 is our missing number. Okay. The next question, if the LCM of a pair of numbers is 36, the product of these numbers is 108, what is the GCF? So we already know that A times B is 108, so 108 should equal the GCF, which is the thing we don't know, times the LCM, which is 36. So this one, if we just divide 36 into 108, we can find that GCF, which should be 3. So that is the greatest common factor. All right, and then this last one is a challenger. So it says the LCM of 2 numbers is 144. The GCF of the 2 numbers is 2. Neither number is 2, so what are the 2 numbers? Okay, so what do we know? So there's 2 numbers multiplied together. That product should be the same as the GCF times the LCM, so 2 times 144. So we know whatever the 2 numbers are have to multiply to make 288. Okay, so let's just list out the possibilities of what could make 288. So we could have 1 and 288. What else? We could have, well, I guess before I say that, the GCF has to be 2. So is the GCF between 1 and 288 2? Do they have a factor of 2 in common? No. So it can't be that one. So what would be next? 2 and 144. Now it can't be this because it says neither number is a 2. So it can't be that fact. What about 288? Does 3 go into 288? Yes. So what about 3 and 96? Do 3 and 96 have a common factor of 2? No, because they have a common factor of 3. So it can't be that pair. What else? What about 4? Does 4 work? 4 times 72 makes 288. Does 4 and 72 have a common factor of 2? So I believe 4 does actually go into 72 18 times. So actually their greatest common factor would be 4. So it's not that one. Let's see, 5 is not going to work. What about 6? 6 should work since 2 and 3 worked. So what about 6 and 48? Well, is their greatest common factor of a 2? No, because 6 divides evenly into 48. So their greatest common factor would be 6. So it can't be 6 and 48. What about something times 7? That doesn't work. What about something times 8? 8 and 36 work. So could the two numbers be 8 and 36? Do they have a common factor of 2? Well, no, because 4 goes into 8 and 4 goes into 36. So they don't have a greatest common factor of 2, so that won't work. Does 9 go into 288? Yes. So 9 and 32. Do they have a common factor of 2? So no, because 2 doesn't even go into 9. So that's not going to work. We having fun yet? So checking 10. Let's see, 10 won't work. 11 doesn't work. 12 and 24 are possibilities. But obviously their greatest common factor would be 12. 12 goes into both of those. So that's not that one. What about 13? No. 14? No. 15? No. 16? So it's probably this one, 16 and 18. What would do they have a common factor of 2? If you take a 2 out, you'd be left with 8 and 9, which they would not have anything in common. So our answer is 16 and 18 are the mystery numbers. Okay. So remember, there are 4 different ways that we can find GCDs and LCMs. So we have the making a list method. We have the prime factorization using a Venn diagram. We have the stacked division method. And then we have Euclidean algorithm. So for your homework, I have given you some word problems. This starts on page 119 and goes all the way till 121. So there are 9 word problems. So you just have to find the answer. So first of all, you have to determine if this is a GCF problem or an LCM. So remember, greatest common factor we use for making smaller groups. The answer would be smaller than what you start with. And then the LCM is a multiple, so it would be an answer that is larger than what you started with. Okay, so for this homework, I am going to grade this on correctness on just the answer. So you can use any of the 4 methods that you want in order to do these problems. So whatever you like the best, whatever you choose is totally fine. So you have until Saturday to complete this homework and submit it. And let me know if you have any questions.